All right, we're here at Formnext 2024. We're gonna wander the halls and see what's going on. This episode is brought to you by Squarespace. What is this? This is a Sovol. Is this new?
Yeah, it's new.
Oh, okay. All right, well, we're just wandering around looking at stuff and we found a new Sovol thing. It looks like their take on a Voron V0. This one is coming out soon, though? Is this a new announcement?
Yeah, next year, February.
Oh, okay. Wow. This I could imagine being quite popular.
Oh, really?
Yeah.
Yeah, I hope so.
Do you have any other information on it, like pricing or?
Maybe $420 more. That's been not settled yet.
Okay, James was showing me this forming machine, and it's like that, like the pin thing that you can use to copy your face, but it's mechanically actuated. I'll try and cover up the reflection so you can see it. And you see it's pushing those pins up one at a time to produce a three-dimensional shape. Or it's pushing them two at a time. Oh no, there's more. There's like 4, 5, 6.
There's 6 total.
Okay, so it just pushes those pins up to a specific spot and locks them in place, and then you can use that as like a rigid, either a tool holder or like a forming mold.
Yeah, it's a vacuum forming mold.
Wait, here's a tool holding example. So it's just conforming to that shape. And then
we've got things like the car, that's what's being formed right now.
Okay, so you can just throw a piece of plastic over the top, melt it, and...
yeah, pull a vacuum, just do traditional vacuum forming.
Okay, and this is Featus. Fuse, okay.
Because it fuses.
Here's the Centauri Carbon. It's basically a Bambu Lab clone. Elegoo, Orange Storm Giga. There it is. We saw it last year. It's still pretty cool. I like Big Tree Tech stuff because it tends to work pretty well, and you get a lot of stuff for the price. So here's the Voron AMS thing. You can do multicolor printing with your Voron. So if you want one of those, I guess you know where to get them. All right, here's some Bambu Lab A1 upgrades. Looks like a blower fan and a little face. It's kind of cute. I don't know how they're able to communicate with the Bambu Lab firmware. That's probably got to be challenging. Ooh, and then they've got this really cool build plate. Look at that demonstration. It's able to print all that and it stays stuck. That's really insane. Okay, and then we got all the main boards here. That's a tough resin that can pound nails. Very cool. Okay, thank you. We're still waiting on the frozen Arco to come out. Guess we'll get it one day. Here's the Prusa booth. Now the big news here is the Prusa Core 1. Looks like a nice little printer. It fixes a lot of the issues that I have with most of the Core XY printers these days being unserviceable. This, on the other hand, is very, very serviceable, so if anything breaks, you can fix it. Yeah, that's what we like to see, serviceable bearings. Made out of mostly stamped steel parts, so it should be pretty cheap to manufacture. We'll take a closer look at one of these later, but I do think it's a cool machine. Let's take a look at the Prusa XLs, the only tool changer on the market. It's been that way for quite some time. Here's another 3D print, multicolored. Very little filament waste on this bad boy. All right, here's the MMU3. I have one of these. Wow, this panel looks impressive. This is all metal. Ooh. Ooh, that's nice, all metal.
You're the ones who bought the test unit. He was talking about that.
Oh, this is Disrupt Engineering.
Really awesome.
Okay. It looks like it's basically just the Rat Rig VOR 4, but like all metal. Here's the VOR 4. Very cool.
That's the pinky.
It's got this hybrid belt system. Got 2 colors there. These things are very affordable for what you get. A gigantic print bed, high speed, customizable.
Is there any possibility?
Hybrid motion system that gets you better Y-axis performance. Lots of cool stuff going on there. We've got 2 print heads going at the same time, and they're just making batches of parts here. I'm confused how all this works, but it looks like it's working, so I won't question it. Mitutoyo. They make everybody's favorite calipers. I mean, they're like $100. There's a big printer. Big printer. Whoa. I want this. Can I get close to this? Just this about, okay. Wow. That's a lot of plastic. I'll get one of these in for review eventually. 3D printed concrete. This is cool because concrete's cheap and you can make all sorts of cool, durable parts with it. Okay, now let's see. We've got a Bambu Lab. I guess they're showing off their new ecosystem of toys you can print. Unfortunately, they don't really have a lot of 3D printers to show off here. They have a little game. These people are fighting with the robots, so yeah. I guess Bambu Lab builds robots. Here's a bolt counter. Yeah, let's go. Nice. Now we need to do it with like candy or something. Okay, let's just go see what else they have here, if they actually have any printers, or if they're just showing off some parts. Yeah. No. All right, there's a Bambu Lab printer right there. There's one there. There's, oh, hello. There's another Bambu Lab printer, X18. Okay, so here we're at the Creality booth. We've got the K2 Plus. Here's the co-print, which they're, teaming up with Creality to produce. Kind of an interesting little collab there. And then this thing is new. This is the Ender 5 Max. So it's 400 millimeters cubed, and max print speed of 700 millimeters a second. Looks like it's just set up to do a single color right now. It's using a similar motion system as the K2, but they're using those larger diameter pulley gears for the XY motion system. So that's what's helping them reach those higher top speeds. And the motors are absolutely beefy. You can see how big they are. They're producing enough torque to just power through those higher torque requirements of those larger pulley gears. But in the end, you get higher speed. And this print head looks pretty nice. It looks like it's using the older generation of K1 extruder. Not a huge fan of that, but maybe if they're using a new hot end. Okay, I can't pull that off. I probably just ruined that print. It looks like they've got a nice electronics bay down here where you can put all your stuff. I like that electronics panel. It's just nice and simple. It's got quad lead screws. So each pair of lead screws on the left and on the right is driven by its own stepper motor. Then they've got their older products as well. So here's the K1C, and there's a Featus nozzle upgrade. I would definitely spring for that if I was printing with a K1, because having a good old Featus upgrade is a good idea. And here's another K2. Here you can see they've been running a HueForge print on this machine. It's just a good printer. Got the Falcon 2 Pro, not a laser person. Then there's the Creality Falcon Basic. Looks like the lower cost version of the Falcon 2 Pro. And here's the Pellet printer. I see it at every show. These should be more popular. And then over here we have Polymaker. They've got their Fiberon filament, their Panchroma filament, all sorts of colors and textures. This is pretty incredible, actually. Wow. These are really nice looking prints. They got the high quality designers making models for them. This is Fulv by Fulv, a very talented maker of doll houses. Here's a Voronoi ball that's spiky. Mimaki, they've got lots of multicolor resin 3D prints with a little Inkjet technology. So you can print out little architectural models in full color with dissolvable support material and clothing too. Wow. If you're enjoying today's coverage of Formnext 2024, then you'll probably also enjoy hearing about today's sponsor, Squarespace. With Squarespace domains, you can purchase your very own domain name. Let's say I'm really into 3D printers, so let's just type in 3D printer. Now 3dprinter.com is probably already taken by somebody, but it'll show you a bunch of different alternatives that you can get. These are all great things. Or let's say you have your own business selling prints, or you just want to make a personal website showcasing all of the projects that you're working on. Squarespace domains could be a great option for you, so you can just buy the domain name and then get started with Squarespace's web building service and build your own website using this all-in-one platform. If you're looking for some last-minute Christmas gift ideas, then this could be a great fit. Let's say there's someone in your life that's working on a 3D printing business. Well, you can buy them their very own web domain, so if they want to get their business started, then they'd be able to reserve their domain, like my website, nathanbuildsrobots.com. Here I'm hosting a bunch of my web articles on conference coverage, and it's just a more professional platform where I can share my thoughts in more detail. So if you want to build your own website or reserve a web domain, head to squarespace.com/nathanbuildsrobots and you can get 10% off your first website or domain name purchase. Now let's get back to our conference coverage of Formnext 2024.
Sunlu Failure Driver E2 is our new product, which can heat up until 110 degrees.
Cool to see. I guess we'll have something to dry out really high temperature filaments now. Here we have the co-print booth, multicolor filament printer for basically any printer you want to put it on, as long as it runs Clipper. And then you can also make it run Clipper if you want to, using some one of their chroma boxes or chroma sets. We'll go into more detail on the dedicated video there. All right, here we are at the Flashforge booth. We're going to check out some of the stuff they've got. So there's a bunch of different filaments. And then over here we've got the Adventure 5X, which is the multicolor printer. And it feeds 4 different spools of filament into this system on the side, and then that goes up through this series of tubes into the print head. So it's similar to the way the Bambu Lab A1 AMS Lite works, but it's in a Core XY machine, and also all of the spool holders are attached to the side of the machine, so it's a little bit more convenient to move around. I'll probably get one of these in for review, so I'm looking forward to trying it out. But for now, these are just like, beta test units. They're not quite ready for prime time. And then over here, we've got this multicolor printer. This one's gonna be much cheaper than other multicolor printers. It looks like they're trying to pack up everything and get rid of this for, oh, hello. They're trying to get rid of this because the show's kind of wrapping up at this point. It says do not open, but apparently it's going to let you print out multicolor models. So pretty cool stuff. Oh wow, this is cool. I've never thought about using this as a strain visualizer or displacement visualizer. So you can run your analysis and then print out a real model of what it looks like and kind of inspect where the strains are. That's pretty neat. I don't know if that's entirely necessary, since you can just, look at it on your computer screen, but I think this would make for a heck of a presentation. Oh, there's the laser doing its laser thing. Very cool. That's like a visualization sheet of sorts. All right, here's a pointy print. Very pointy. I don't know what any of this is, but I'm just looking at it. So, wow. It smells like ABS over here. They've got a vacuum pump running right now to transport more pellets to the print head. And look at that volumetric flow rate. That's nice. Okay, and then we got eSun over here. eSun has a K2 Plus. Here's the Mingdas. Maybe I should get one of these, the MD1000. Wow, that's a big printer. That's a giant printer. I think it's an IDEX. Okay, I don't think I quite need one of those. This seems more my style. big IDEX machine. This is a pretty large dual extruder. Look at that.
They are
Big prints.
They are really
Wow.
control, really precise.
Here you can see the print speed. Here's the parts. Ooh. Pretty tough. Big drum. This is the brand. Creality to make these giant parts. Oh, someone bought this printer. I need to put my name on here. Just scribble that out and then it'll be mine. Look at this. That's some good marketing right there. Some more tiny prints, but this is just made with a normal laser type process. But it, I mean, it's got to be special to be that small. So these are the build trays. Very cool. We need a better camera to be able to actually see these. 3D micro print. Okay. Wow. That one's cool too. I don't know what that is. This is just printed in one piece?
Yes.
Wow. Okay. There's special chainmail. Cool stuff there. And here's some really interesting architectural stuff. They're using concrete and all sorts of other medium. But the coolest one, in my opinion, is this multi-material hollow strands by blow extrusion. Now, this is a hollow tube of plastic, and they're basically extruding this and puffing it with air at the same time. So it's super lightweight, and all these extrusion paths are hollow. And they even did it on a much larger scale here. It's really lightweight, and it's a pretty amazing process. Then over here we've got some plaster and rebar or concrete and some different brick concepts to spice up your architecture if you're making brick buildings. And this one's kind of neat. It's just a bunch of blocks that stack together, and then fungus grows in between these to lock them in place. The Myco lock. There's a lot of creative uses of 3D printing here. Very cool. So this is silicone printing on a Bambu Lab A1 Mini?
Yes.
Wow.
Not exactly, but we'll get to that.
Okay.
Okay. So this is the first silicone parts printed on a regular FDM machine. Let me explain. We start from an empty tube inside our factory. We fill it with any paste material like silicones, chocolate, ceramics, different resins, any paste material. The user needs to only replace the nozzle. This takes 5 seconds on a bamboo. The paste goes inside here. The tube goes around and is pulled by the extruder. Later it is cut and goes away for recycling.
You know what this reminds me of? It's like the sausage factory. They have the
Great.
casings.
This is the reverse sausage factory.
Okay.
Yeah, and the paste is deposited and printed. So why this wasn't printed yet on a bamboo? Because this is a two-part silicone. So it was printed on a dual extruder machine.
Okay.
With a mixer below. But we plan to put the two parts of the silicone inside a single tube with a membrane between them.
Okay.
So it will be able to print silicone on a Bambu Lab.
That's very clever. And you don't use the heater, or maybe you use it a little bit?
Not for silicone.
Okay.
For chocolate you need to.
Okay.
To temper it.
Yum.
That depends on the material. Whether you need to heat it or
Okay, filament 2.
yes. That's
Very cool.
Can we have your
Start going again. So this is the silicon carbide crystal.
Yeah, this is crystals, exactly. But then there's printing materials here in between where they are a mixture of a thermoplastic binder. So when you heat it up, it becomes liquid, and when you cool it down, it becomes solid, and the powder is inside. So now you take that and you put that to a print head, and this print head will then, because it's heated, also jet a liquid with the powder still contained inside. And now 2 different print heads with 2 different of this mixture, so you put different powders into this different print heads, now will deposit droplets with very different materials inside, but next to each other. And so they overlap, and then because of cooling, they will, after fusing together, just become solid again because thermoplastic binder. And so now you have this solid body similar to like a wax, let's say like a candle, where you have this different material powder spaced inside. And with this spacing, now you have achieved that, okay, it's basically a multi-material part, but to get it dense, you have to debind it. So you take the thermoplastic binder off, for example thermally, and then you take that scaffold of all these distributed powders carefully, put it to a sinter kiln, and then it sinters. So there's a diffusion process which makes it actually a solid dense body.
Okay.
And this we can achieve for very different combinations of materials. So for example here now, as the easiest thing to see is that you use different pigments to make it light up in like different colors, for example. Or you could use pigments to I'm not sure if the camera will see it, but you can make it luminescent. So but then also you could, for example, use it for tooling, where the edge, the blade is harder here, while the core is tougher, you know. So for the different mechanical properties, and from there it goes to other combinations. For example, over here we show the really like across material classes where you have zirconia and stainless steel together, or have like a glass and pure copper together, or a glass-bound ceramic for very good dielectrical properties together with a silver or other precious metals to have very good either like boards that hold up to temperatures where usually your plastic as an insulator, electrically speaking, would already have disappeared, or
it's PCB.
It's not a PCB, so PCB has the plastic. In this case, it's ceramic inside, so this can withstand, let's say, 200 or 300 degrees application temperature. So this is a replacement for PCB, let's say.
Okay.
You can make electrical circuits and so on with this. And then down here, this was screen pitted on top, basically a piezo ceramic together with some conductive gold traces. But the plate was done with what we call multi-material jetting. Everything that I explained right now was done with this technology, and where you have spaced very different pores. So deliberately by size and by location, there are pores inside, which then makes the whole thing an ultrasound transducer. And from there it goes to, for example, other electrical features in insulating ceramics. This is called the silicon nitride molybdenum disilicide compound. There's different mixtures of this. One is electrically insulating by nature, and the other one is doped so that it becomes electrically conductive. And now you can integrate electrical functions again into a matrix of electrically insulating material. And so you can have, for example, running like paths, like through connections of electrical pathways, or for example make a resistor inside. And these parts you can heat within like 2-3 seconds to like 1,300, 1,400 degrees.
Wow.
So this is shown on, for example, for this little forming tool here, that, you know, maybe you need to form something on this side and you need to heat it only at the top. So here you print the coil, the heater coil, right underneath where you wanna shape. Then you have conductive traces running through. You have even cooling channels running through. Maybe you want to cycle between hot and cold, and also it keeps the shaft cold, so you can mount it to like maybe a robot or something. If you now imagine you would have to create this or manufacture this in a different way, then you would likely think of an assembly. But the assembly in this case would be how you do it. You maybe mount some peak part to your which is expensive, to your robot, and then the next thing that happens is you have to put, you know, something for the forming, which should be hard and abrasion resistant, maybe even chemically resistant. Like here the ceramic is already by itself. So and then you need some cooling channels, some heater somewhere, you need to run some cables, you need to maybe put the housing around, and so on. And all of this, even if you get it assembled at this either small form factor, so miniaturized, or even in a bigger form factor, even if you would get it assembled, likely it would fall apart if you heat it now at least at 1,000 degrees, but also at lower temperatures, because everything has a different CTE, like thermal expansion coefficient. And so this is an assembly that you can just print instead of having all this headache.
Yeah. And could you make like a 3D printer nozzle, like an FDM nozzle out of that?
I suppose yes.
Okay.
I suppose yes. It's just a matter of like putting a hole into like. If it's a nozzle, usually it's kind of like a how's it called, like a cylindric shape that then changes the diameter, right? So I don't know. In German it's conisch. I don't know what the English term is, but like.
Yeah. You could heat it exactly at the nozzle.
Just where the hole should be, you keep it open, and then around you just put that heating coil inside the material, like print it as a single part.
Okay.
Yeah, so it could be done, and then you can do many on the machine, which is here on the wall at scale. So you see the print bed is about 530 by 300 by 200 millimeters, with like up to 6 materials, because here up to 6 print heads is modularized, can be pre-configured like this, and on top there's a laser inside, so the whole machine is laser safe, which is an additional module that can be either come pre-configured or later be added if needed, to increase surface quality inside and outside, because it can laser on every a laser machine on every layer. So for example, melting the binder, so that then everything is kind of leveling out, which leads to surface qualities of at least in the green state of about 0.3 micrometer, which is RA, which is pretty smooth already. And then from there you go to either inner or outer surface, because you can do it on every layer. But then you could also structure, increasing the surface area to maybe have a better heat exchange, or for example structure in a way that you make really sharp edges that you couldn't achieve with the drops itself by resolution. So increase resolution in the end.
Okay.
To make even better parts.
Well, I wasn't prepared for a full dissertation, otherwise I would have set my camera up better, but very interesting. That about wraps up my time at Formnext. I hope you enjoyed seeing a little bit of what it's about.